Okay, great. Sorry for that, guys. During my previous recording, the postman came and sort of disturbed the flow. So I'm just going to start it all over again. So one of the reasons why I'm recording this video is because the video I recorded yesterday was not very good quality. So I want to do this with so you can actually see the text and enjoy the coding tutorial. Now, hopefully within 5 minutes, I'm going to demonstrate how you can deposit funds in the any.sender and how you can use any.sender to relay all of your transactions for you. So you can literally plug into a very simple API and get production ready, transaction infrastructure. So in any.sender, we have a central contract called the relay contract. The purposes of the relay contract is mostly to do financial accounting and also to record evidence that we did our job. So what's really cool is that all you need to do is deposit funds into this contract and you can start using the any.sender service. So that's what I'm going to do now. I'm going to copy the address, I'll go to MetaMask, and I will deposit, let's say 0.3 ETH into the contract. My little MacBook Air is a bit slow, so let's just give it a second. And there we go. We're now going to deposit 0.2 ETH directly into our relay contract. After 12 confirmations on Ropsten, this balance can then be used in any.sender. So we'll use this money to pay for all of your gas. Okay? And that's the only reason, you have the deposit into it. You do a prepayment, and then that takes care of your gas costs going forward. So that's cool. Now, what I've also done is I've pre-deposited some money already, so we don't have to wait for 12 confirmations. And our goal today is that we're going to use any.sender, and we're going to send a transaction to the echo string contract. An echo string is a really simple contract. All it can do is it takes a message, and it's going to emit an echo. So it's going to publish data to the world. We're going to use any.sender to send a transaction to that contract. So let's go look at the contract, or our code, in our tutorial, and see what it's like. So in our example here, what I need to do is I need to fill in an Infura ID, and I've already done that. Please don't steal my ID because I don't think you're supposed to share Infura IDs, and EG might kill me for doing that. And 2, you need your private key. So the way any.sender works is that when you deposit funds, we associate that balance with the signing key that deposited funds. If you're going to do a direct send like we did. So what we're going to do is go to MetaMask. We're going to export that private key and put it straight back into our tutorial script. I don't normally recommend exporting private keys and copying and pasting them around. But for the tutorial, it's much easier to do. There we go. So I'm going to reveal my private key. Please don't steal my 0.2 Ropsten ETH or my any.sender balance. That would be embarrassing. So we're going to paste that in, and now we've set up the wallet and we've set up Infura. So let's go look at the example code and let's see how hard or easy this is to do. So let's scroll through here. We have the contract address already in the script, the echo contract that I spoke about, and we have the ABI. We can ignore the ABI for now. It's a bit long, cumbersome to talk about. So when you use Ether.js, you normally have a wallet object called user wallet. And this has, your private key creates, a wallet and you can sign messages from that. What we have to do is connect it to the provider. You normally have to do that anyway. And then we wrap it in the any.sender, functionality. Actually, what I forgot to mention is that you need to install the library as well. So we're going to use the experimental library for this. Any.sender client. You need to do npm I and install this experimental library. What's cool about the experimental library is that it takes care of contract wallets for you. And we're going to go through this now. So every user will have their own contract wallet and the library takes care of all that for you. Now what we do here is that we do any.sender account and we put in the wallet itself. What we're doing here is that we're wrapping all the any.sender functionality around the wallet. We don't interfere or remove any of the functionality from the wallet, we just add functionality. And now we have a user any wallet. If we scroll down, here is the echo contract, and we're going to wrap encode the function call, and we're just going to emit a message that says sent by this user wallet at this time. That's all we're going to emit from the echo contract. And then what we're going to do, just for the purposes of illustrating how this works, we're going to check, does this user have a contract wallet? Has a proxy contract wallet already been deployed? Now, in our example, I've never used a signing key before, ever, not even with any.sender, so it doesn't actually have a proxy contract yet. So what's going to happen is that when we send our first transaction to the network via any.sender, your client library is going to do a batch call. It's going to deploy the wallet contract and then send the transaction out and call that echo contract. And it'll do that within a single Ethereum transaction, so it's all atomic. So that's really cool. From a developer perspective, you don't even have to worry or deal with the proxy contract whatsoever. And now we're finally going to get to the fun bit. We're going to do user any wallet .any.send transaction. And as you can see, it doesn't look any different than normally sending a transaction. We're going to send it to the echo contract with the data, and we're going to set a gas limit. The main difference is that you no longer set a gas price. Because what any.sender is going to do is that this code will get your transaction, give it the any.sender, and then any.sender will take on the role of sending that to Ethereum, gradually bumping the fee until that transaction gets confirmed. So you don't have to set a gas price because any.sender does that for you. And the whole point is, we're always trying to get in at the right, network price so we save you money. We're a bidder. We place a bid, we bump the bid until it gets in so you don't overpay fees. But that's cool. We just do any.send transaction, and that takes care of sending it to any.sender for you. And also deploying the proxy contract. And then we just do the regular .wait, and now any.awesome. Cheers, Liam. But now we do .wait, and then we're just waiting for a confirmation, just like you normally would with Ether.js. And then when you get the transaction receipt, you can get the transaction hash, and it's going to give us a really nice Ether scan link. Then we're going to check if the proxy contract was actually deployed. So let's actually just send it and see if it works. So I'm going to do node wallet example.js. And now we've just got to wait until it sends. My laptop's a bit laggy. So we can see here the proxy contract doesn't exist yet. It's false. The transaction's being sent up to any.sender, and any.sender is now taking on the job of bumping the fee and trying to get that in Ropsten. Now, Ropsten can be a bit unreliable sometimes in the sense that you could wait 2 minutes for a block. Last night it was on fire and it was giving me blocks every 5 or 6 seconds. So now we just got to wait until, until Ropsten actually makes a block. So what we can do is spy a little bit. We can just look over here and we can see that the transaction has been broadcast. It was broadcast 26 seconds ago. When was the last time there was a Ropsten block? Let's have a look. There was a Ropsten block roughly 1 minute ago. So we're just waiting on a new Ropsten block for the transaction to get confirmed. If you guys have any questions, by the way, while we wait for Ropsten to actually make a block, I'm more than happy. Oh, there we go. You don't need to ask me any questions because it's confirmed. So that's cool. You can see we relayed after 1 block. Ropsten was just pretty slow minting blocks. You can see our message to this link. So we click the Etherscan link. It's open up on the wrong browser. So let's go over here. And we can see the message that was broadcast in the echo contract. And I think that's just really cool. It just did everything for us. There you go. Hello world, sent by this address. And it was done at this time. And now we can see the proxy contract also exists. So our client library took care of all the replay protection, deploying your wallet contract, sending the transaction out, and guaranteeing that it gets in the blockchain. And it's, as you can see in the code, it's a really good developer experience. All you have to do is wrap it in any.sender account. You just did a normal send transaction. You get a normal receipt, and it did everything for you. So what I'm really hoping is that we'll get some developers picking up this API. You'll basically get production ready, transaction infrastructure out of the box. It's going to save you months of development time because this took us months to develop. And now you can get, reliable you can get transactions delivered to Ethereum in a reliable manner. And that's actually why we built it. We just want to help projects, deploy faster and get their projects up and running. So that's basically any.sender in a nutshell of how it works from a coding tutorial perspective. I hope you guys enjoyed it as much as we enjoyed making the code in the example. I'm going to also leave a link in the tweet, I guess, of the tutorial that I just used. Thanks for listening, guys. I know that took slightly longer than 5 minutes because I talked too much. Sorry for that. Okay. Bye-bye.